Hi, this is a quick video presentation of solving applications for hyperbola. One of the reflection properties of a hyperbola makes it very interesting, such that if there are light rays directed towards one of its foci, this will now be reflected to the other foci. So this is utilized in various optical instruments. Further, it is identified that there are heavenly bodies in our solar system that have parabolic orbits. It is noted that about 70 comets follow hyperbolic orbits. Hyperbola is also unique because it is the only conic section which is also studied in non Euclidean geometry. So this is the word problem that we have. We already know that one of the applications of hyperbola is through LORAN, or the Long Range Navigational System. So let's have this word problem. LORAN navigational transmitters A and B are located in those points -130 and +130, respectively. A receiver, point P, that one on a fishing boat, is located on a hyperbolic path, and it listens to the transmission of both A and B, thus being able to compute their difference in distance to be 240. The question is, the questions are, what values are given based on the problem? What will be the values of A, B, and C? And then letter B, identify the coordinates of the different essential points of the hyperbola, such as the foci, vertices, and co-vertices. And lastly, determine the standard form of equation of the hyperbola. So if I would be solving this, I would begin by plotting the point, or identifying the hyperbola itself. Okay, so you have point A here and point B, excuse me, as your receiver, or as your transmitter. So since these two are your transmitters, then these would serve as your foci. Okay, so this would be foci 1 and foci 2. Focus 1 and focus 2, I'm sorry. And then this is a point in the hyperbolic path. Let's create a quick drawing over here in this section of your hyperbola. Say this is your y-axis and your x-axis, your y and your x-axis. Let's plot the points again. We have point A at -130, and then we have here point B at 130. Okay. And then we have point P somewhere along the hyperbolic paths. Let's say we have these this hyperbola now. How did we know that the hyperbola would be facing left and right? Well, because we have our foci on the x-axis. Therefore, parang yung parabola lang yan. Kung nasaan yung focus natin, dun nakaharap yung branches. Okay? So we have this. So from the graph, we are able to identify that this is a case 1 hyperbola. Case 1 hyperbola opens to the left and to the right. Next clue, we have a difference in distance of 240 kilometers. The difference in distance serves as your transverse axis. Therefore, it means that this distance is 240 kilometers. So, kung itong distance na to ay 240 kilometers, tapos alam nyo naman na nahati siya dito sa center or sa origin, then that means this small distance here would now be 120. Kasi 240 itong buo. Itong kalahati niyan, 120, 120 yan. So kung 120, 120 yan, analyzing from these facts, we now are able to identify the vertices here. O kung from 0 to 120, then that means this is now 120, 0. And this is -120, 0. That would be the coordinates Those would be the coordinates, okay? Next, so if we have the coordinates of the vertices, then let's take note of the other given values that we have. We know that it's case 1, and then we also know the coordinates of the foci. Again, kapag Loran siya, kung nasaan yung mga transmitter, yun ang nagsaserve as your foci. So we have positive, negative, 130, 0. From the transverse axis, it measures 240 kilometers. So translating that as units, we now were able to identify the vertices, which are positive, negative, 120, 0. Ayan na yung alam natin. From these values, we are able to extract, from the foci, we are able to extract C from the foci and A from the vertex. So let's put that here. We now know that the C value is 130 and the A value is 120. Moreover, we have positive, negative, 130, 0, and positive, negative, 120, 0. Ang kailangan na lang nating kunin is B and the co-vertices and the standard form of equation. So let's remember the formula in getting C. Yun lang kasing meron tayo. C is equal to the square root of A squared plus B squared. Now, we are looking for the value of B alone. Ito yung kailangan natin. To be able to get that, we have to square both sides. We are squaring both sides to be able to cancel out the radical. So, we could transpose to the other side. So, magkakaroon yan tayo ng C squared is equal to A squared plus B squared. Eh, si B squared yung kailangan natin, di ba? So, we transpose A squared to the other side. Don't forget to change sign, ha? C squared minus A squared equals B squared. We are looking for the value of B. So, we get the square root for both sides. B squared is equal to, binaligtad ko lang C squared minus A squared. Parehas lang yan. And then get the square root for both sides because we are just looking for the value of B. We now have B is equal to the square root of C squared, which is 130 squared, minus A squared, which is 120 squared. And then having that simplified, we arrive at B is equal to the square root of 5,000. 5,000. And getting the square, is it 5,000? No, it's 2,500 because we have 60,900 minus 14,400. You could use your calculators here. So we will arrive at 2,500. Therefore, B is now equal to square root 50. Alright, there you go. We have 50. B is 50. So, since we know the value for B, we will be able to get the value for CV, 0, positive, negative, 50. And lastly, we are able to determine the standard form of equation. Since it's case 1, the formula now is x squared over a squared minus y squared over b squared equals 1. Substitute the values. Ladies and gentlemen, we have x squared over 120 squared minus y squared over 50 squared equals 1. Simplify the values and our final answer for the standard form of equation is x squared over 14,400 minus y squared over 2,500 equals 1. And this is now our final answer for the standard form of equation. And we're done solving our word problem. Thank you so much for tuning in. Happy learning.